Hello, everyone, and welcome to the weekly live stream of the Platformers community. And today we are going to talk about how to revolutionize your cloud infrastructure with self-serve. And for that, we got our special guest for today, Ofir Shlomi. Ofir is the team lead for the backend platform team, and Shlomi is a tech lead in the team. How are you today?
We're great. Thank you, Guy, for inviting.
Yeah, it's awesome. Great to be here.
Thank you for joining. I saw this stream, I think it was 2 weeks ago on a local meetup that you did, and I think it was an amazing meetup, and the session is amazing. I'm just sharing with the viewers that are joining us that this is absolutely a game changer with how we can implement infrastructure self-serve on your own. Before we start and dig a little bit deeper into how do you do that and what challenges have you had, I want to just let everyone know, if you have any questions, feel free to post it and comment it so Ofir and Shlomi can answer for them. You just can paste it on comment on YouTube or comment on the LinkedIn video, and we will be able to help us and pop in. So Ofir and Shlomi, what are we going to talk about today?
Yeah, thanks, guys. So today we're going to talk about our self-service platform, and actually we're thrilled to share it with the world. I think everyone who joined us today made a great choice because you will learn some practices that you can apply in your organization in order to solve some bottlenecks you may have and streamline processes and make developers happy and also free infra and DevOps and platform to do much more exciting work. So let's get started.
Sounds amazing. If you can make developer, DevOps, and platform engineering happy, sounds like an amazing goal and achievement.
Absolutely.
For sure.
Yeah, so we'll start. Actually, our story starts with the typical workday in a life of a common developer in many companies, which kind of can be kind of frustrating. And it looks sometimes, somehow, and it looks like this. So the developer begins his day, he prepares himself some coffee, he writes a few lines of code, and then he hits the first wall when he realizes he needs to extract some data from an S3 bucket, which he doesn't have access to. So he reaches out to DevOps, security, to infra to get permissions, and maybe he knows someone personally, so he gets help immediately. But in most cases, DevOps are busy people, so he'll have to wait maybe an hour, maybe two, and then he manages. And he moves on, he writes a few more lines of code, and then once again, he hits a wall. He realizes he needs to provision a Kafka topic, and he doesn't have the permissions to the relevant central server, or maybe he needs to provision a new Lambda or a queue or some other resource in his relevant cloud provider. And once again, it's not really what he does day to day. He's not fluent in Terraform provisioning, and maybe he's not allowed because in his organization, only DevOps people are centralizing the resource creation. So this is an experience I'm sure many developers in the audience had, and you don't really have enough time and enough valuable hours in your workday. And when I go to the DevOps or infra members, I don't think their experience is much better. A typical workday for them looks like this, where you are completely flooded with requirements from R&D to help this developer and that developer to gain access or provision a resource. And I'm sure many of you know the feeling of starting a day with a set of tasks and finishing the same day with 4 times the number of tasks you started. So I'm sure you're familiar with this, and no worries, we're definitely here to help to solve this and make your life much better. And we are the platform team at MyHeritage, and we do all kinds of stuff, many platformers here, so each platform team defines itself a bit differently. So we have all kinds of buzzwords here like cloud infrastructure and developer experience, environments, and so on. But if we put all the buzzwords aside and try to define what we actually do or our vision in, let's say, a sentence or two, what we aim to do is solving the bottlenecks to 100 plus developers at MyHeritage and letting them focus on what they actually want to work at, which are business domain problems, and not fighting with infrastructure they don't understand and don't love. So we try to do that by providing them the tools like self-service to actually abstract all infrastructure away from the developer and letting him focus on what he loves to do. So I'm Ofir, I lead the backend platform team, and Shlomi is here with me. Shlomi led the self-service project and will do the second part of this talk. So we're at MyHeritage, and for those of you who don't know MyHeritage is quite a unique company that touches the lives of our users each and every day. And MyHeritage does that by connecting you to the most important people in the world for you, which are your family members. They can be like close family members or maybe distant ones, maybe even ones you didn't know they exist. And the way we do that is by connecting the data of the user, which the user enters the website, it builds his family tree, maybe it takes a DNA test, and we will be in charge of automatically connecting the user to the billions of family tree profiles we have in our databases, billions of historical records like birth, and marriage, death records, and so on, and millions of DNA samples. So together this, both the genealogy and the genetic aspects of your research will reveal some amazing discoveries that may lead to exciting reunions of families. We hear about these almost every day here at MyHeritage. So going back to self-service, or maybe going even a bit before that, why even self-service is needed. So I want to remind us of how an old school resource provisioning looked like, or how it looked like in MyHeritage before we had self-service. So it all starts with a developer, and the developer gets a task, and he thinks how he's going to do that. Maybe he does a short design phase, and then he realizes that as part of this task, he will need some resource, maybe a bucket, a lambda, a queue, and so on. And as we said earlier, he's not fluent with Terraform, and he doesn't really know how to write IAM policies, and so on. So he decides to open a ticket, and this ticket reaches to DevOps team and joins the pile that we saw earlier. But soon after, the developer realizes that the DevOps people here in the middle of the picture in the yellow shirt is flooded with requirements. And what you can see here is you see people from different teams trying to pull the DevOps person to actually handle their request. And in our organization, it was done by convincing that the actual task that you asked for DevOps to do is much more important than others, because DevOps weren't able to get to all tasks in a reasonable time. So the organization had to prioritize. And let's assume as a developer, I had a very good debate skills and I was able to convince that my project is the most important one. Then I will start to wait to DevOps, because DevOps has a lot more work to do. They also do upgrades and maintenance and monitoring production and whatnot. But finally, they will get to my task. And then I will soon realize, in this table tennis, the ping pong, that DevOps knows what I need, what me as a developer need, in much more detail than me. For example, if I requested a bucket, DevOps will start asking me questions. Listen, do you need your bucket in IAM rows or in ACLs? Do you need versioning for your objects? What about encryption? What about audit logs and inventory? And so on and so forth. And we'll start figuring it out together. And then DevOps will probably create the CloudFormation template or Terraform code and provision the resource. And then I'll have the resource maybe in staging, maybe in production. But those of you who provisioned resources before knows it's almost never working in the first try. So then I'll realize I'll try to maybe connect it to my app and realize it doesn't work. Obviously, DevOps now moved to help another developer or maybe doing other work. So I'll have to wait again and go back to the ticket and do this cycle over and over again. And maybe I'll do it 3 or 4 times. And finally, after a few weeks or maybe even more, I will get my resource up and running in production, but it will take a long time and be very, very frustrating.
It's very interesting. Like, how do you manage to prioritize, like, DevOps do your work or the other work? Like, how do you prioritize those tickets or tasks?
Previously, we had in the end of the planning of each and every sprint, we had a meeting where all team leads from all teams came to a meeting with DevOps, where they tried to convince why their project is more important and should be handled. And sometimes the one with the best debate skills would have be able to convince, and he made his project prioritize even higher than more important projects. So this was like a per sprint ceremony we did, and we were preparing to it and trying to convince why we need it and we need it now. And yeah, it was an experience. Obviously, we wanted to improve.
So it's amazing to see like how in order to become a really good team lead, you should have a really good debating skill with the DevOps team and the other team lead, and you need like to push yourself into it. But it sounds like a very frustrating meeting. Like how do you prepare for that? Like you need the argument, you need to prepare a lot of stuff. How do you prepare for this meeting?
Yeah, you have to know what works. You have to know what touches the management. You have to know what makes value. You have to understand your project in a way that will, and sometimes you even have to understand the other team's projects in order to have some benefit over them. So it's funny process to have, but it actually has some benefits because you need to understand the requirement much better than if you would have get it for nothing. But absolutely, it can be frustrating because sometimes you simply don't win. Sometimes, as much as your debate skills are good or not, sometimes your project is less important than others, and you have to wait or you have to find some solutions. For example, I didn't get a bucket, but okay, I'll add a prefix for another bucket, which is not logically correct, but it will take me 2 steps further. Or if you'll go with the Lambda, okay, I don't have a new Lambda provisioned now, but I'll create a new endpoint in an existing one, which again, it doesn't really make sense, but okay, let's do that in order to progress. So this kind of balanced or decisions or some trade-offs, we didn't want to get there, but
Wow.
we.
Oh my God, it sounds not terrible, but sounds like you need a lot of creativity skills to convince,
Absolutely.
to fight, to decide when you want to lose in order to win the other time. Are you really excited to hear like how do you manage to solve that? How do you manage to remove those meetings
Yes,
out of
we
your
actually
plate?
worked like that for years. And as you understand, there are a lot of drawbacks in this approach. And we decided to think how we can solve it. And by solving it, we try to do this. This is a version of self-service, but if we think of what self-service is, and let's assume these guys here are developers that are coming to collect their food, but let's make self-service a bit more interesting, at least as much as ChatGPT was able to write some code. You see, he managed to do some things right, like compute, but he wrote the databases instead of databases, so we'll forgive him to make a point. And what is the point? The point is we want to make a self-service buffet where you will, as a developer, will arrive to our buffet and select from existing recipes. We, as platform team, will prepare for you in advance. We know the patterns that work best at MyHeritage because we saw a lot of patterns on each resource. We saw a lot of buckets, we saw a lot of cloud functions or lambdas or queues, and we know how to prepare these recipes, which will fit the vast majority of the cases. So the idea, in a nutshell, is for you to just come, pick up the resource that you want, and get to work, get started without interfering DevOps or any other infra member. So how is this achievable? So first of all, if you want to make this accessible for developers and attractive for them, developers, as you know, are lazy. I'm a developer myself, so I can testify that we don't like to write ACL, HCLs, or CloudFormation templates, or JSONs, or YAMLs, or all those kinds of declarative languages. We do our best by writing code, by writing coding languages. So we want the developer to be able to write code that defines his resources, something he can understand. And also, we don't want only the top-notch 10% or 10x engineers to create resources, but we want to make it accessible to everyone. So we have to hide the underlying infrastructure and make it available for everyone to both write, provision, and understand what they do, so they'll be able to monitor it. Also, obviously, if we have a self-service platform, we had legacy, so no company starts with self-service from scratch. It usually comes from pain, like we had. So previously, we had some resources provisioned in let's say plain old Terraform. For example, when I'm creating a self-service platform, I want to be able to provision resources, for example, provision an EKS cluster, when my VPC maybe is already provisioned in the past in plain Terraform. So I have to be compatible to what I had before. Moreover, life is always complex, so we want to make it working in multi-environment, production, development, staging, and also in multi-accounts. We have dozens of AWS accounts at MyHeritage, and sometimes there are cross-account requirements. For example, I want to have my Lambda running and triggered by creation of an object in a bucket, and this bucket may reside in a different AWS account. So I have to support these cases. Also, we want to avoid running things manually like Terraform Apply. You want to make this platform easy to run by GitOps, and we'll touch this later. Shlomi will show it in the demo. Make it reviewable, make it run security scans, and do everything that will make it as easy and streamlined as possible. And here we get to standards. So we talked earlier about the example of a bucket. So in a bucket, there are a lot of choices to choose when you provision a bucket. It's not easy. We talked about inventory and encryption and versioning and auditing and more choices. And as infra, as platform team, we can build and insert to our buffet, to our self-service buffet, recipes of buckets. Let's select 2 recipes as an example. One recipe is a bucket that is open to the world, open to the internet, and maybe it's accessed only through CloudFront distribution with signed URLs. And this bucket has certain policies that you don't have to repeat every time you provision a new bucket from this type. And on the other hand, I may prepare a recipe of a bucket that is closed. It has different policies, obviously. It has only specific set of VPCs that can access it. It maybe has different tagging and auditing for this bucket because it's more sensitive. So I want to have this as another recipe the developer can and should choose from when he needs this kind of use case. And here we get to our golden path. And in this golden path, you know this, as you platformers, you know this golden path approach. So we are very opinionated. We will choose the relevant default for each and every use case, and we'll let developer just come to the buffet, choose the recipe that you want. And if you want to steer away from the recipe, the opinionated one that we prepared for you, go ahead, you can do that. We'll allow you to. Obviously, there's the price for that. But for all this theory, I want to take you forward and move the mic to Shlomi to take you to the practice.
Thanks, Ofir. And yeah.
By the way, if there are people that watching us and you have any questions, please just post it on the chat, on Twitter thread, on YouTube comments, on LinkedIn, and whatever you like. Just small note. By the way, it's a great, like the slide that you ended it with, Ofir. I think it's great, like the golden path and the fact that people can build recipes and they get your approach and your standards to how they can go, like walk through the golden path. But on the other side, they can also navigate not on the path. This is amazing because it really gives flexibility, but also ease of use, which it's amazing approach from what we see compared to the other more structured and opinionated approach toward that.
Yeah, so thanks, Ofir, again. Thanks, Guy, for the clarification. And again, thanks to everyone who joined. So I want to discuss then what's the solution we have here. Ofir presented many requirements, the ability to do things automatically and by a certain standard and with a clear and accurate golden path. And how do we do that? So the answer is quite simple. It's a combination of infrastructure as code and proper CI/CD system. So let's talk about those 2 aspects. So the infrastructure as code aspect, this can be provided with multiple technologies. We have Terraform, which is an industry standard. We have CDK, Pulumi, and others. and as we'll see also CDK for Terraform. So let's see which one we'll actually use here. And there's CI/CD, which means that we're going to use GitOps and an automated way to actually use that code in order to provision resources without running them on dev machines, without having manual intervention for these steps, and maybe relying on permissions and such. So we'll talk about both aspects, more on the infrastructure as code side, but we'll also touch the CI/CD aspect a bit. So the first infrastructure as code technology we want to discuss is Terraform. So Terraform, the popular and beloved tool for provisioning resources, and what we'll show here is a very simple demo of provisioning an S3 bucket, an IAM role, and the ability to say that this IAM role has read access to objects on the bucket. So this is how we'll do it. We'll first declare that we're going to use an AWS provider, which means we're provisioning resources on AWS. Terraform supports thousands of different providers, sort of a plugin design. And each provider supports all sorts of resources. So we're going to declare that we want an S3 bucket. We're going to give it some test bucket name, tag it with some tags on AWS, then create some role, and point it to some policy that we're defining below. Then we define the policy of who can actually assume the role, and another policy document which says what the role can actually do. Notice we already reached over 50 lines of code here for doing something relatively simple. And in the end, we took the document, placed it in a policy resource, and then attached it to the role. We did this in 63 lines, and this is something I would have been happier to describe in like 3-4 sentences, which means like 3-4 lines in code. So as a developer, this leaves me quite frustrated, right? Because this is a lot of code to describe something fairly simple, but in a very verbose way. Now, verbose but powerful. But for such a simple use case, we really want simple code too. So this is where frameworks like CDK come in. So CDK, the Cloud Development Toolkit developed by AWS, allows you to do exactly that. It provides you strong abstractions for resources on AWS, and it gives you those abstractions on top of a programming language. So you can use TypeScript or Python or Java or C# or whatnot. And you write all this code, and then it translates behind the scenes to CloudFormation templates, which AWS executes. So in this case, we do the same. We define a bucket. We instantiate a bucket object. Then we instantiate a role object. Then we call a method on the bucket objects, grant read to the role. So overall, we describe this in like 3-4 sentences, if you will, which is what we want, which is awesome. This is exactly what we were after. But unfortunately, not so much, because CDK is an awesome tool. It's a great tool, but it's only relevant for AWS resources. And in our organization, we are provisioning resources on many systems. We're provisioning not only for AWS, but also for HashiCorp, Vault, and Consul. We're provisioning even Kafka topics using Terraform. We're provisioning resources in GCP and so on and so forth. So we're actually using all what the Terraform providers can offer us, and we use that. So obviously we cannot do this with CDK, and we need to look for some other solution in order to have a full service solution for all the types of resources we want our developers to provision.
Yeah, I think it's amazing to see how the technology evolves. Like we started with Terraform, which is kind of allow us to do, but you need to know, as you said, like HCL, you need to do a lot of this. You need to know a lot of this stuff to learn how they are connect, and Terraform got its own behavior, which is kind of different from any program language that I worked with. And then CDK, which looks like program language, which is, I don't know, JavaScript or whatever, but it behaves more like Terraform in the way it behaves. So, or when you deploy the CloudFormation stack, that's amazing.
Yeah.
So I'm looking forward to hear about more solutions.
For sure, me myself as a developer, every time I need to pick up like a new declarative language, which is a totally different syntax than anything other I've seen, I kind of, curse a bit and then go ahead and learn it. But for sure, developers prefer to work usually with something similar to what they know, even if it does something completely different. But at least syntax-wise, it's kind of more intuitive. So this is what we're after. So there's the combination of CDK and Terraform, which is called CDK for Terraform. And what it does, it offers some kind of a bridge approach, which says you can use imperative programming languages such as TypeScript, Python, and whatnot, and you could use those to write code where basically each resource you provision is going to be a class generated from Terraform resource definitions. So basically, you're writing Terraform in a programming language, but not in HCL. And then what CDKTF does behind the scenes, it compiles the code you've written. Then it synthesizes Terraform from the code you wrote. And then it actually executes Terraform behind the scenes. So you have all the thousands of providers available to you, but you wrote object-oriented code. So which gives you this ability to actually enjoy the best of both worlds. So let's see how it actually looks like. So this is how it would look if we use TypeScript with CDK for Terraform. So we instantiate a provider, and again, same example, bucket role, and the ability for the role to have a read access to the bucket. So we instantiate the provider, then we instantiate the bucket. We instantiate a data document for the assume role policy. We instantiate the role. We instantiate the policy document for the access to the bucket. Then we instantiate the policy which references this document, and then we instantiate the attachment. Well, that looks kind of familiar. This is exactly what we did with Terraform like 3 minutes ago, right? So I'm still frustrated, but this time I'm frustrated in TypeScript. So it's a ton of verbose code, and I'm basically getting the same experience. So what am I doing here? Is this really a good solution? Well, turns out that if you abstract it well enough, it is. So at the bottom layer, you have CDK for Terraform, which is what we just showed. And then you abstract it with all of the buffet, if you will, of different resource types that you want to abstract as an organization. So we abstracted away some AWS resources, some GitHub resources, Consul, Vault, Kafka, and some GCP resources. And all of those abstractions, all the code that hides some of the Terraform complexity is provided to you. But you can also use escape hatches. That is, you don't have to use only the abstractions. You could also write like pure object-oriented Terraform-like code if you wanted to do something out of those abstractions. So you have all the freedom. And on top of that, you have a CI/CD system. What we use is a third-party system called Spacelift, which is basically a CI/CD system for resource provisioning. It supports Terraform, it supports CloudFormation, CDK, and all those tools. So it can actually run Terraform. And as we said, we have Terraform code right here, because CDK for Terraform synthesizes code, Terraform code from the code rewrite in an object-oriented fashion. And then all those abstractions are packaged in a neat NPM package, which our developers use. This package is called the IAC toolkit. So let's discuss a bit what our requirements from those toolkits are, besides providing all those nice abstractions. So we want security. We want all of our, let's say, security requirements already provided as part of the logic of provisioning the resources. That is, we have we know that already all of the MyHeritage buckets are by default not open to the world, then that logic is going to be in the abstraction. If we know that we don't allow like non-HTTPS traffic, that's going to be part of the code of the abstraction. And other common patterns and standards too. For example, tagging. So we have like default tags for everything that allows us, after the resources, are provisioned, to actually backtrack from them back to the code that provision the resources. And we have sensible defaults and resource naming that is standard. Again, to MyHeritage, it's very opinionated to what we do. Of course, we are after simplicity and velocity. We want the code that we write to be very simple to write and extremely simple to read. When you read it, it's going to be very simple to understand what resources are provisioned, at least at a high level. We want this to be extendable. So we're providing this toolkit to many teams in our organization, and we want them to use it. But if they're missing something, they can easily extend it. They can create new constructs or new classes, but constructs is like the CDK name for it, that provide the abstractions that they want. And if they want to extend an existing abstraction, they can just extend a class, override some method. So we want it to be very, very open to changes, but closed enough so it's going to be clear what exactly you want to override.
So do people like get this kind of, they allow to define what they want, or what you allow them, or just something in between?
So we do have a bunch of policies in Spaceleaf that say what you absolutely cannot provision, sort of a blacklist. But other than that, you can basically provision whatever Terraform support. So nice. you can, if you're missing the abstraction, you can go ahead and do that. And then we even have other teams submit pull requests into our toolkit, so other teams can enjoy that as well. So it kind of grows organically within the org.
This is something amazing about culture, what you just mentioned. Like this, like when you define this toolkit that allows people to use it, become like an inner source community for this toolkit. So you're not the only owner of it, and if someone needs enhancement, they can do it on your own. This is an amazing achievement. I think it's absolutely shows the I culture and the I involvement of people want to be close to this project, be close and make stuff really useful in your organization. So I'm really happy to hear that, because it's amazing.
Yeah, for sure. It's like a mini open source, if you will, project in a way.
So some companies like do work for like call it inner source, like open source, but internally, which is kind of in between. And at some projects, some companies make it really successful. And then turns out to be like those people that contributed over the years became like the leader of the project. So it depends on what you want to achieve, but people really want to get involved.
Yeah. So hopefully we'll maintain that momentum and have more people contributing and making this even a more meaningful thing to the org. And finally, we require multi-amp support. That is, we want the stack itself to be to be provisioned on multiple environments like prod, staging, dev, envs, but without changing the code between the environments unless you must do that. So the toolkit itself is env aware. That is, it gets environment variables from the CI/CD system that tells it which environment and account it should provision the resources under, and it takes care of the rest. And if you, as a developer, want to do special things in special environments, you can just add conditions and build your code around that. Not something that we recommend internally. We do want people to provision the same resources on the same environments, but sometimes you want to scale things down on different environments or test other things. So we definitely allow to do that as part of the toolkit capabilities. So let's see how it actually looks in actual code. So I'm going to stop sharing this slides, and I'm going to share my entire screen. And all right,
I will add it. Okay, there you go. Now we can see your code.
Okay,
yeah,
great.
Yeah.
So this is our demo stack. Our demo stack extends a MyHeritage base stack, which is part of the toolkit, but this code is the actual stack code that I want to provision. And I declare all sorts of things in the constructor, which band is deploying this, what's the workload, and so on. And then we actually provision the resources. So I'm going to comment this out and see what we're actually going to provision. So we have a builder pattern that we use to build our bucket. This is slightly different from the CDK approach, but it's quite similar in the way you read it. So we build a bucket, my Terraform test bucket with some mandatory parameters. Then you build the IAM role, again, using the same builder pattern. And then you call a method on S3 bucket called allow access, which says I'm allowing read permissions on the bucket to the role. So I'm going to commit this code as part of a branch called platform as demo. So I'm going to provision resources. Okay, so I push the branch, and then I'm going to open a pull request for that and see what happens. So I can already see I have this run here from Spacelift that is now initializing. So this is interesting. I'm going to open that and see what I get. Okay, so I see that there's something initializing. TypeScript is compiling.
Maybe you can share a few words about Spacelift just in general for people to understand what do they see.
Yeah, for sure. So Spacelift is a CI/CD system for resource provisioning. It hosts all these stacks that each one is basically like a Terraform workspace or a CDK-TF stack or a CDK stack, and it actually allows you to manage the whole life cycle of the resource provisioning, the plan phase, the review phase, and to see that the plan actually did what you wanted it to do, confirmation flows around that, policies that let you define who can provision which resources. So you can do everything using GitOps, but then you have another set of guardrails that protects you. So you can prevent teams from shooting themselves or others in the foot. So in this case, we opened the pull request, which triggered a proposed run, which basically means it's just going to show us the Terraform plan and then stop. So you can see it finished, but it didn't really apply any changes yet. it just creates all those resources. So we can see that it shows us the resources, the actual Terraform plan output. So you can see that we created a default policy document for the bucket. You can see that it denies access from non-secure transport channels. This is something that me as a developer, I didn't like write that explicitly, but I got that from by default from the bucket builder abstraction, because it's something that we as an organization want.
Yeah, this is the golden path that we discussed earlier. This is exactly a great example for that. Like, we have opinionated views on how it should look like. This is an example for a security approach, but you can also see it later in some of the choices we made and defaults and so on. We guide you as the developer to go on this path, and obviously we'll see other examples here below.
I think what is also amazing is that developer do get more of a code-based solution that allow them to spin up and create whatever resources they have, but they are able to track the creation from here and get a really friendly UI that embedded some of the path and the golden path that you paved into, for example, the security, but into the UI. So it's kind of mixed solution, although it looks like in the first hand like a really code-based solution only.
Yeah. And to continue my train of thought here. Then we have this policy document which shows that you can you have the policy that says that you can list the bucket objects and get the bucket objects. And we specify this with like a single line of code, and now we have like a full policy which is hidden within the abstraction. And another policy. No, this is the actual policy object, which points back to the policy document. And the IAM role with the assume role statement, and you see it's actually very verbose in the end, but I had to write very little code to actually reach those set of changes that actually created like 12 different resources behind the scenes, but I only explicitly created like 3. So this is the actual plan, and when I look at the pull request, I can actually also see it here. So I see that I have the 12 resources to add. I can look into it over here, which is really comfortable. If I as a developer, I don't really want to go to see the full Terraform plan or even go to Spacelift. Just want to see that my pull request did what I intended it to do. So then I'm going to, and don't try this at home, but I'm going to merge this without waiting for any approvals. Usually I would, but for the sake of demoing, let's just go ahead and merge. So what's going to happen is I'm going to see a new tracked run in Spacelift. What a tracked run means is that it's actually going to be applying the changes and track those resources I've created. So you can see that under the stack we have resources. Right now nothing is provisioned, but once they will be provisioned, we'll see them here. And right now we can also see the same TypeScript compile, synthesizing, and so on and so forth. So while it actually runs synthesizing and planning again, I'm going to show you how it looks like behind the scenes in the toolkit. So this is the toolkit code, and right now we're looking at the bucket builder, and we can see that it extends a base builder. So there's like all sorts of builders that share common code. And then if we go to the build resource method, you can see that it does a bunch of things behind the scenes. It configures versioning, and it blocks public access. It configures life cycle for the bucket, inventory, and so on and so forth. And in life cycle, you can see that we have this lifecycle configuration that is derived from rules that we got in a with lifecycle rule method. and we have all those lifecycle rule builders. Like we have, let's see, we have expiration lifecycle rule builder and storage transition and so on and so forth. So we have kind of this rich lifecycle rule builders, and developers can implement more. And we also have, if we look back at the builder, we have all those other with methods, like with allowed IPs and without versioning, which means that with versioning is like the default. Again, as we said, very opinionated. And we have, as you can see, all those resource types abstracted away, like IAM roles and ECS and CloudFront and Route 53 and so on and so forth. And we have GitHub resources that are abstracted in Kafka topic builders. Even space configuration itself is configurable via the toolkit, and it's growing every day. So let's go back to our tracked run. So you can see it's waiting for a confirmation. Okay, so confirmation to what? So confirmation that the plan we're seeing here is what we actually wanted to provision. So we see it's the same as before, but that's not always the case, because if there are stacks that are being updated a lot by different developers, then the tracked run plan can be different from the plan that we saw in the pull request. So we are required to reconfirm here, and that's what I'm going to do. And once I'm confirmed, it's going to provision all the resources for real this time. So not just a plan, but now it's going to run a Terraform apply. So it does a small preparation, and any moment now it's going to actually run the apply based on the plan that we saw earlier. So it's creating the resources, it applies the changes already, and now I can see we have 12 other resources, 0 changed and 0 destroyed, and our resources are provisioned. So we have them all here. So that's it for the demo for now.
An amazing demo, I have to say. Before me moving forward.
Thank you.
Yes, so it was indeed a great demo. And it was only, I believe, the tip of the iceberg of this platform. And we'll see a couple of more examples as we go forward. But just to recap where we were before we had self-service. And if you guys remember this movie, The Wild Wild West, and this is where we were before we had self-service, if you remember what we talked about in the beginning. So we had manual resource creation by each and every one that people were actually Terraform applying from their own machines and from servers without any auditing, and obviously no reviews and no standards whatsoever were enforced. And also GitOps was something we were very, very far away from. And obviously no code reviews and security scans is the way another level. And as a result of all this, we had a very slow development cycle. We talked earlier about the process of actually getting things done by DevOps as a bottleneck to create resources. And this is where we were. And the DevOps office looked like that. And DevOps were flooded with requirements and didn't get any other significant work done. And today, we are actually proud to celebrate a 1-year birthday to our platform. And our platform in 1 year had a lot of other achievements. So Shlomi showed us a very nice approach of bucket building. But let's say I want to provision an SQS, for example, an SQS, in a queue, I want it to be a FIFO queue, have a dead letter queue, and a visibility timeout of 1 minute. And with 3-4 lines of code, I have an SQS on production. Another example is SNS, which I define encryption and SQS subscription for it. And bang, I have my SNS on production with a lot of other settings and defaults and decisions made in the background for me as a developer by the platform team. This is a much more complex example, so I'll try to say it a bit more slowly. This is an ECS cluster that is based on auto-scaling group, and this auto-scaling group is working on top of an SQS. So we have a queue. This queue is triggering auto-scaling events, and these auto-scaling events are creating the auto-scaling for the ECS nodes. And in here, the developer actually defines which instances he wants to get, for example, G5 extra large. And this is actually a very significant family of projects in MyHeritage where we have like machine learning training or anything related to that, where we want an ECS cluster which is based on GPU instances, and see how simple it is to provision. Then we move away from AWS to something else, to Kafka topic. And here we decided as the infra platform to reveal the partition number and replication factor and retention days and other settings. Obviously, we have defaults for these. And then see how easy it is to create a topic. This is another system. This is a configuration system that we manage internally. And this is another example for a bucket, this one with much more things that developer decide to override. For example, he said without versioning. So from this, you can infer that the default is with versioning. And if the developer wants to steer away, he can. Also, we defined some lifecycle rules, and he allowed specific VPCs to access his bucket. Also, he managed, see how easy it is to define managed access in the last row to a service like Athena that needs access to the bucket. One line of code, and you have everything in the background, all the policies defined. Also, we manage everything with iron roles, so you see how easy it is to create and provision resources, and also we are adding new resources as we go forward. And in this year, we had hundreds of resources explicitly created and by our developers, and our developers didn't even know that, but they actually provisioned thousands of resources behind the scenes, because if you remember this example we saw in the previous slide for an ECS cluster, so this cluster behind the scenes actually provisions something like 50 resources, because you have here VPC and subnet and security groups and CloudWatch alarms and auto-scaling groups and SQS and ECS and node groups. So, and I can go on and on and on, and you can understand the complexity that is hiding behind the scene here, and how convenient it is for the developer to create, override what he needs, and that's it. So this is a great achievement for us. And the results obviously speak for themselves. In a year, we have 52 repositories made by our teams. So these are 52 repositories created by 16 different teams, and 16 is all the teams that we have at MyHeritage. So it means that 52 different projects, completely different projects were created using self-service. So this is way above our expectations. And in most projects, we didn't have any dependencies in infra or DevOps because of this infrastructure. And on the way, we were able to standardize resource creation across all accounts and across all resources in all teams, and create it by human-readable code. We have code that provision resources. Everyone can monitor and maintain it. And obviously, as Shlomi showed us, we have the full GitOps process. Everything has a review, a PR, an auditing of who and why, with security scanning. So the streamline of the processes got us to our results. And we did recently a developer experience survey with 115 participants. And our relatively new self-service platform gained one of the highest rates, 92% satisfaction rate, and we're still hunting down the other 8% of the developers. So last slide, if you have to summarize, so a self-service infra such as this will help you to spend more time on your activities. Also, you can free DevOps and infra to do some more meaningful things. So everybody earns, the developer gains independence, and also on the way you are able to enforce different standards, and even its security or development standards, as we discussed the golden path throughout this talk, across all the resources in the organization. And maybe most importantly, as a result of all of this, you have accelerated processes. It's easy to do POCs, to provision resources, to destroy them and provision again in another environment or something different. So processes and projects start and accelerated much, much faster than they used to. So we'll summarize by saying this is, this is the way how we see it to accelerate your projects in your organization. And as important, make developers, make DevOps, make infra much more happy from their day-to-day. So thank you, Guy, for inviting us.
Thank you, Ofir and Shlomi. I think this is amazing because getting into like 1% adoption of anything and get also 92% satisfaction score. This is just amazing, and see not only that you created a good solution that can work technically, and this is what Shlomi showed us in the demo, but it's also getting adopted and being used. So this is absolutely a blast. And I have to say, like, thank you for coming in here and sharing it with us, because that gives a lot of influence and a lot of ideas within the community to understand what other people do and how they solve it, and how people would manage to be successful when they create self-serve. So first of all, thank you very much for joining. Thank you very much for sharing this topic and subject. And thank you for all the audience that actually joined us during the session. If you do want to watch other stream on the next, we are doing a weekly live stream, and every week someone coming and sharing a story with us. So Ofir, Shlomi, thank you very much for sharing your story with us today. And everyone, see you next week. Thank you very much.
Bye-bye.
Cheers.